about the minor presentation for earthwork, water reticulation, costing and estimating for Group 6. So first is the earthwork. So for the introduction part, earthwork is the process whereby the surface of the earth is excavated and transported to and compacted another location. There are four main processes in earthwork, which are excavation, transportation, unloading, and compaction. In earthwork, there are three types of work, which are site clearance, excavation of trenches, and foundation and bulk excavation. Now I'll talk about the site inventory. So for the site inventory, any conditions on the site that affects plant, water, and people should be noted on the inventory and analyzed to make the best design decision about stormwater management, family activities, and types of plants. We can determine that the area of site is 49.12 hectares. The highest original ground level is 88.99 meters, while the lowest original ground level is 31.17 meters. The particular land is covered with 95% of plantation, as you can see in this map. Now I'll talk about the site analysis. The purpose of this analysis is to provide throughout the information about the site access and liabilities prior to start the design process. So first is surface protection and drainage. Runoff from both the slopes and the upslope catchment area should be cut off, collect, and lead to convenient points of discharge away from the slope. The second is the design of fill slopes. The fill slope is at one vertical to two horizontal angles depending on the subsoil conditions and the material used as fill. Now I'll talk about the proposed level. So the proposed level is set by the considering existing topography of the site area, including the existing facilities such as the existing road, existing drainage. We determine the proposed level for each zone by taking the average of the highest and lowest reduced level for the zone, so we can minimize the difference between the cut and fill volume. For now, we get into the cut and fill. The software or AutoCAD Civil 3D to assist us in computing the cut and fills. The manual calculation and population process, manual grid method or cross-section method is quite tedious and prone to errors due to human mistakes. So the results of the software calculation are more accurate than those of manual calculations. Any correction or amendment can be easily done by simply adjusting the evaluation of the proposed area as required. Now, where to perform it? So we need to have two surfaces to calculate their difference. The first surface is the existing level surface. We can creating an existing surface from the points with elevation where we obtain from the surveyor. After extracting the points from points with elevation text, we input them again into the AutoCAD to make them points with elevation. Besides, we also change the text with IL, inverted level, to propel the elevation to prevent errors. Lastly, we created the existing surface by selecting all the points with elevation. The second surface is the proposed level surface. With the discussion a moment mentioned, we have decided that the proposed level for each building and route according to the existing surface to obtain the best design with the minimum net cut and fill. Next, by using a new layer, we have drawn the 3D polyline with different elevations respectively depending on the different buildings and roads. So small margin was reserved between each different elevation to ensure that our proposed level will not change, since AutoCAD will automatically build slope to bridge to different elevations. Hence, we did not leave some gaps between the buildings with elevation. The elevation of the same building will change gradually and become gradient. Finally, we created the existing surface by selecting all the 3D polyline and putting them into the contour selection. Now we go to calculating cut and fill. So we use two methods. One is the thin volume surface method and the second is grid volume surface method. So both of them have created. This is the report, and there has the cut and fill volume, and also it creates the net volume. From the thin method, the net cut shows 35,148.7 meter cube, and the percentage of net volume is about 3.48%. For grid method, it shows 12,601.32 meter cube, and the percentage of net volume is 1.32. So both methods shows the net cut and fill volumes are lower than 15%. Hence, our proposed elevation for the area is acceptable. Now we go to the cross-sectional view. After computing the cut and fill volume, we produce three cross-sectional views, which is at AA, BB, CC, and one long sectional view, 3DD. The red part indicated the cut area, while the green part indicated the fill area. Now for the cross-sectional view, the step to create a long sectional view DD using Civil 3D. So under the panel of the Create Design, create alignment by drawing fixed line between 2 points. By clicking on the alignment drawn, we can then create profile view under panel of lawn patch. So choose two surfaces, existing surfaces and proposed surface, station range, provide view, height and display type based on the needs. So the cut and fill area hatch can be performed by choosing the correct surface for upper and lower boundary. Step to create the cross-sectional view AABBC using Civil 3D. So under the panel of the provide and section views, create sample lines on the design station along the alignment. Then create section view, create section view. So and choose the sample line that you desire to create the cross-sectional views. Then we're choosing the appropriate display type, layer, elevation range, and also the section view can be created successfully. This is the picture. The graph shows the cross-section area for AA, BB, CC, and also the DD. Now we go to the last part, which is slot stability. The B-short simplify method has been used. As you can see, this is the picture of it, and then we use the calculation for the first trial, R equal to 15 meter, and finally we get the 2.1. The FOS, the factor of the safety, which is larger than 1.7. So the calculation FOS does not match with the assumed FOS. Therefore, we try another one, which is the R equal to 30 meter, and finally we get the 1.7 FOS, which is similar to the 1.7 here. So it is acceptable for this. So we stop the trial. Now we go to the water reticulation part. Now I will talk about the introduction. For water reticulation is a water distribution network which is delivered to the consumer, such as residential, commercial, and industrial once the water has been collected and treated. Water distribution system consists of three pipelines. First, transmission pipeline from treatment plant to reservoir. Second, distribution pipeline from reservoir to reticulation pipeline. Third, reticulation pipeline, pipelines within the demand area. So the water reticulation system component includes storage tanks, booster pump and suction tank system, type of pipe used, type of joint used, type of valves and use is the sludge valves to stop flowing water, particularly for the maintenance. Then firefighting pipe and fire hydrant, domestic water meters and firefighting meters, and truss block or anchor blocks. Now we go to the design part. The majority of the project building reticulation pipelines are analyzed using a closed looping pipe network. The Hardy cross or head balance method is utilized to calculate the residual pressure head using Bernoulli's equation. Figure out the exact pipe diameter that will give the satisfactory residual pressure head at each node. The domestic water supply pipe must be designed together with the firefighting pipes. EPANET system software is used to analyze the simple distribution network to determine the velocity, flow rate, and pressure head for the Hardy cross method. Now we talk about the steps to use EPANET system software. So first, draw a network representations of your distribution system or import the basic description of the network placed in a text file. Second, edit the properties of the object that make up the system. Third, describe how the system is operated. Fourth, select a set of analysis options. 5. Run a hydraulic/water quality analysis. 6. View the results of the analysis. Now I will talk about the head loss. The loss across an equivalent length of the strap pipes can be used to calculate small losses such as those brought on by the through valves and fittings. So we use the Hazen-Williams formula to calculate the head losses. Now I will talk about the design of the water tank. So in this picture, it shows all the necessary parameters used to design the water tank. And from this design of water tank, we need to see that the water tank must be located at the highest point on the platform level. Next, we need to know about the peak flow rate. So peak flow rate is equal to the average flow times peak flow factor, where peak flow factor equal to 2.5. So we need to know all the locations, different locations, the peak flow rates, and we sum it up. In total of 31 nodes, the total water demand equal to 881, 12.77 liter per day represents the designs of the water tank. Next, by using the EPANET software system, then we need to know the knot design. So we have total of 31 knots there, so we can simulate it and we can get the elevation, demand, and pressure. We need to get the adequate one so we can able to design it properly. Now this is the pipe design. The pipe design involves all the head loss. So the maximum permissible flow velocity in any pipeline is to be set as 2 meters per second as stated in the Suruhan. So all the design must be within this range, and all the design has been come out by the tabulations from the EPANET system. This is the design layout showing that all the 31 knots on the layout plan. Now we go to the third part, which is the costings and estimating. So first, introduction. Estimating is the process of predicting the cost of construction project by comparing the project to a similar one that already have been completed. So costing is the process of calculating the overall cost of a construction project, considering all aspects such as labor, materials, equipment, costs, and taxes. The cost estimator needs to know the magnitude of the project, which type of material they intend to use, what their labor rates are, what construction equipment they need to hire, so on. Now we go to the earthwork specification. So the earthwork should consist of necessary site clearing and grubbing, cutting and removal of trees, excavating and backfills of structures and trenches, soil compactions as it is required for the completions of the workup to the formation level. Now we go to the earthwork machinery. There's the dump truck, the transportations of the various loose materials such as sand, earth and gravel, chainsaw used in activities such as tree felling, leaping, and the pruning, cutting, fire breaks in wildland, fire suppressions and harvesting of the firewood. And then excavator, used mainly for the digging purposes, bulldozers, clear shrubbery, and then the obstacles and the remains of building and structures, backhoe, the sections of excavating equipment and compactor to material soil through compaction. Now, the process to obtain cost of random operating machines. So the cost per meter cube for the dump truck, cost per tree for the chainsaw, cost per meter cube for excavator, cost per meter square for the bulldozer, and cost per meter cube for backhoe, cost per meter cube for the compactor. Now we go to the cost estimations before reduction and after reduction. I'll talk about the first activity, which is the site clearing. Then it consists of the tree cutting, tree disposal, tree roots and stump removal, topsoil removal and transportation, excavated topsoil. So in this activity, there's the cost per day we calculate, and then we also calculate the total cost before the reductions, and we compare with the total cost after the reductions. This is the tabulations of all the results. Now we move to the cut work. So the volume of work need to be cut before reduction. We get from the earthwork group. So this value is from the tin method. So the tin method, this volume times with the soil swell factor, we can get this volume. And then volume of the earthwork need to be cut. This one is from the grid method, which is from the earthwork group also. And then we times with the soil swell factor, we get this volume. So we use both of this volume to use for the calculation of the cost per day, and we get the total cost before reduction for the cut to formation and also the transport cut soil. And then from there we also calculate the total cost after the reduction part, so we can get this result here. Now we move to the field work. So the first is the volume of earthwork need to be filled before the reduction. This one is from the tin method, the fill part, and the volume of earthwork need to be filled after reduction. This one is from the grid method, also the fill part. So we use this value to do the fill to formation calculation, and then we get the cost per day, and then we have to calculate the total cost before the reduction, and then also the total cost after the reduction, and we get difference between it. This is same apply to the finishing, where there's the leveling work for the cut and fill method. We also need to get the same result there. Now we come to the compaction part. So as you can see from the above table, this is the total fill volume, which is from the tin method. We get the fill volume from the volume, and then we times to get the 125 consolidation, we get this volume, and the below one here is from the grid method, the fill volume, and then we also use this to calculate the volume, and then from there we need to calculate the total cost of the compaction, which represents the before reduction, also the after reduction. We get comparison between it. Now we come to the summarizations. The total cost before the reduction we get is about 8,524,159.87 ringgit, and then we can see the total time taken for the earthwork before the reduction is about 22 weeks and 5.5 months. And this is the total cost after the reduction. It is about 7,927,130.36 ringgit, and then we can see that the total time taken for earthwork is 18 weeks, about 4.5 months. So we can compare with the before reduction, after reduction, we get the percentage of reduction about 7%.